In this recording, we're going to explore the Claisen condensation in OscerSyn. So here's the one that's the simplest one, a simple ester and some ethoxide, and we'll just press the magic button. And as Oscar looks around, the only reaction it finds is the enolate formation, but then of course in the presence of excess of their ester molecules, it'll do the condensation. The product is the enolate here, delocalized over both carbonyls. This is, of course, the driving force for the Claisen reaction. Now, enolate is probably not what you want for your final product. So what can you do? Well, you, of course, can simply add some water, or you could add some acid, and you can neutralize the enolate. Now, at this ester stage, this is like after you've done a monoalkylation of the ethyl acetoacetate synthesis. This would be the same kind of place. You can decarboxylate. You could intentionally form the enolate and do an alkylation, whatever you like. But let's assume that you were just trying to do the Claisen condensation to make a ketone, in which case we'd want to decarboxylate. And so the way to do this, of course, is to hydrolyze that ester. Easiest thing is to simply use acid. If you add acid here, okay, you will go to the carboxylic acid, and then of course for the carboxylic acid, all you have to do is heat it up. Grab some heat off the menu and heat it up, and you'll have your final ketone down here. So what you're making out of this, of course, is a symmetrical diketone, which of course could be very useful. Now, what if you tried to what if we tried to do a cross Claisen? What is Oscar going to think of that? So what I need is two different esters across Claisen. So let me I don't know, I will just come and I'll put a methyl group there. What happens? Nothing's happening. Why is nothing happening? Well, look down here. You can't fool Oscar. This is a cross Claisen. It gets multiple products. I refuse to think about it. Oscar is not going to do a cross Claisen reaction. So that's not going to happen. Remember, we needed that ionizable hydrogen? What if we put a methyl there? What's poor Oscar going to do? Oscar says, no reaction found. Can't fool Oscar. If you go to the right, form that Claisen product, it'll just go undone. So Oscar's not having nothing to do with that. So that's it. Let's look at something a little more fun. Let's do a intramolecular Claisen. Again, what's Oscar going to do? Well, it sees two esters. It's going to do a cyclic reaction. And again, there's our enolate. And again, we can get rid of that enolate by protonation. Okay, I said I used water last time. This time I'm saying acid. It doesn't matter. And you'll get your neutral acid. Now, if you use some more acid, this assumes you just had a little bit of acid. If you had more acid, the Oscar will assume you want to do the hydrolyzation of you want to hydrolyze the ester, and so. Hydrolyzer, there's the carboxylic acid, and of course, again, if you like, you can grab some heat, and Oscar will decarboxylate it for you. And so this is making a very nice way of making rings. As you can see, we have a ring with only the carbonyl. So this is cyclopentanone, and this is cyclopentanone, and it's a nice clean way of making it. Now, if we just reload here, that was number 2. You see, and let me put a methyl group on here. Now, methyl group, of course, Oscar knows you can't do a condensation where you start off making an enolate here, but we have this other ester. So what's going to happen? Well, Oscar's smart enough; it puts the methyl group on the other side, and so we still have the enolate that we're looking for. And so if you for some other sneaky way you made an enolate on the other side, you would just would end up doing a reversed Claisen reaction, and so this just is a fact. You can only make these reactions work when you form an anion there. So let me do one more case. Here's one. This is a longer ring. We do the same thing. We get a 6-membered ring. And again, if you try to do this with some other substituents, what shall I do? Oh, let me add just add something crazy down here. Okay, so here's, whoops, that's crazy. Let me I don't know. I'll put a phenyl down there just to be. Well, I didn't put a phenyl down there. I'll end up putting it there. I don't care where it is. Anyway, here we go. So again, we're just putting our substituents on there. So what else can we do? Okay, what crossed Claisens don't work because there's just too many products. But in this particular case, there's no ionizable hydrogen over here on this ester, so this will work. And Oscar recognizes, again, there's only one way to do this, and so it'll do the nice, this is a cross reaction, but it's, in this case, you would have to worry about this ester reacting with itself. But if you controlled your rate of your order of addition and controlled your base properly, you could make this reaction work by selectively being careful about how you added your acid and base, so you never had an excess of this ester in the presence of the base. So what you do here is you'd make up one pot where it has the ethyl benzoate with the ethoxide in one pot, and then add this one slowly, and you could do this reaction. So one last thing is to just point out, of course, is that esters will react with other enolates, and so here's a preformed enolate of a ketone, and this reaction will work just fine in terms of the enolate attacking the ester here, kicking out the ethoxide. In this case, you don't need any acid workup because you're going to kick out the O- from the ethoxide to get the final product. I guess actually this should be ethoxide. That's the small error. But anyway, this is how Oscar plays with the Claisen reaction, and you can use it to do all kinds of fun reactions.